Hey guys, happy Friday. We made it to the weekend. Hallelujah. So today we are going to finish up the note outline. So just to continue on with the vocabulary that we were discussing on the previous video, calorie is how we actually measure energy. So it's just a unit of measurement. So have you ever, been told, oh, you're eating 2,000 calories a day, or this candy bar is 500 calories, or whatever? Calories is how we measure the energy that we are going to be getting from that food item. Now, we have good calories and we have bad calories, though. So a candy bar is probably going to provide mainly bad calories. But if you eat, things like trail mix or steak even, those are going to be good calories. So that's what matters, is the type of calories that you're putting into your body. But all of them are going to just represent a unit of energy. Next thing is metabolic rate. So the metabolic rate, there's two forms, I guess you could say, of it. So the basal metabolic rate, BMR, is the minimum amount of energy required by the body in a day. So this would be just your normal living ability. This is nothing extra. So in other words, this is not recess, this is not running, this is not working out. This is literally just the basic minimum amount of energy required to survive. Even if you stayed in bed all day, your body is still using energy. So it's the minimum amount of energy that you need for survival. That's basal metabolic rate. Okay, so we can even put in parentheses here, survival. Okay, so what that means is if you are only using up, let's say, 300 calories a day, but you're eating 2,000 calories a day, are you going to be losing weight or gaining weight? If you said gaining weight, you are right. So you have to be able to burn the calories that you are eating if you're wanting to maintain your weight. If you're wanting to lose weight, you need to, which y'all are sixth graders, so you don't need to lose weight. But if as an adult you wanted to lose weight, then you would have to burn more calories than you eat. If you want to gain weight, then you need to eat more calories than you burn. So it all has to kind of balance out depending on what you want. The total metabolic rate is the sum of your BMR, which is this, and the energy needed to sustain your activity level. So this is going to take into effect all the extra things that you do for survival, like working out, running, jogging, participating in PE, recess. So if you are going to do all of those fun, active things, then you are going to be burning up more energy. So your body is going to require more energy for you to do those fun things. Normalization is the comparison between your body weight and the amount you eat. So in order to essentially kind of figure this out, it's a division problem. So you would take the amount of food that you eat and divide it by your weight. So if I am eating, and it's been a while since I've done this, so I can't remember if the amount of food would be in pounds or calories for this. I would imagine it was probably in pounds. So you would have to measure out the weight of your food and divide that by your weight. So things like elephants, okay, elephants are going to have actually very low normalization. Elephants seem like they eat a lot, but they actually don't. Elephants actually eat very little compared to their body weight. But if you look at something like probably even your pet, because they're more than likely spoiled, they are going to be eating more than their body weight. So they're actually going to be eating a lot compared to what an elephant eats, which is kind of interesting to think about. So it's the comparison between the amount of food you're eating and your body weight. And that will finish up page 6 for us. And moving on to page 7. So page 7, I didn't really write down anything with this. This is just extra for you to look at. This is also in your textbook. It's on page 305. And so this is just talking about those 3 forms of food that we eat. Carbohydrates, proteins, and fats. And it just tells you how it is broken down and what it turns into. So if you eat carbohydrates, then they can turn into polysaccharides, disaccharides, or monosaccharides, depending on what type of carb you eat. And then once they turn into that, then they will eventually break down into a monosaccharide, and then you get energy from that. If you eat a protein, then you are eating the glycerol head and the fatty acid tail. Okay, so this would be the glycerol, and then this would be the fatty acid. Okay, and once those things are consumed, then they break down even more into amino acids, which, if you remember, is one molecule of protein. And then those amino acids will also turn into energy. And then you will also have a little bit of extra protein that you actually will get rid of in your waste, or that will go into your cells and help them do different things. Okay, and then fats or lipids. Okay, you are going to be eating a fat, and remember, it can be, you know what, actually I messed this up. This should be over here where the glycerol is, not under protein. You can tell it's Friday. So this would be your glycerol head. Sorry about that, y'all. I know I probably just confused you. And then these big parts would be your fatty acids. So then the glycerol and the fatty acids, they get broken down into pure energy. So you can see all 3 things that you are eating gives you energy, but you can see that some of them require more steps than others. So you just need to take that into consideration when you are eating your food. Choose good choices that is going to provide the most energy for you with the littlest amount of work. Now page 8, again, I didn't really write anything on here, but this is just to kind of put all of this together for you. If this is really confusing to you, then you can just pretend it's not here, but it breaks down each macronutrient, or they call it a macromolecule. So you have your carbs, your lipids, and your proteins. And then your nucleic acids are way down here, but remember, we don't really need that stuff because it's DNA. But these 3 is what we actually need for energy. So just kind of look at this. Again, if it makes sense to you, that's great. If it doesn't, then just ignore it. I just try to kind of organize it in a different way for you. And that is all I have for you guys for Module 12. I will post a video for the study guide as well so that you can get those answers. And then I'll probably post just one video for the study guide, so you can just pause it as you see fit and listen to it over however long you want to. whether it's over one day or over several days. So I hope you guys have a wonderful weekend, and I look forward to talking with you today on Zoom.